Welcome back to another episode of Impact Evaluation Methods. In this episode, we're going to be looking at what are called regression discontinuity designs. Another method for estimating the counterfactual, that is, finding another control group. Regression discontinuity designs fit best when we actually can rank the eligible population in order of need. In fact, the key is having an indicator of need which is continuous, and that there's a cutoff which determines eligibility. Either above is eligible and below is not, or below is eligible and above is not. And it's this discontinuity which allows us to identify a valid counterfactual. In fact, many programs determine eligibility through the use of continuous indices or scores. Anti-poverty programs target households under a particular income level, so below some income level you're eligible for those programs. Pensions target above some age. Education, sometimes we give scholarships to the best students based on results of a standardized test. Agriculture, we might target benefits to small landholders. We might give a fertilizer subsidy to households that have small amount of land. Consider, for example, an agricultural program designed to improve the productivity for small farmers. The intervention is to buy subsidies for farmers. What we do is we target farmers less than 50 hectares of land, and we exclude large farmers that are bigger than 50 hectares of land. So our running variable here would be hectares of land, and the discontinuity occurs at 50. Below 50, farmers are eligible. Above 50, they're ineligible. Here's the relationship at baseline, before the subsidies are provided, of farm production, or the outcome on the vertical axis, against the running variable, or the score, on the horizontal axis. If the running variable is measured in hectares of land, and the outcome might be yield or production per hectare. Necessarily, the outcome is going to increase with the running variable. The more hectares of land, the more productive the farm is. So we can't just compare everybody above the cutoff of 50 to everybody below, because on average, the outcome would be higher above the cutoff compared to below the cutoff. However, we might be able to use individuals just at the cutoff. Just above the cutoff at 50.1 hectares, farmers are identical, are almost the same as farmers just below, 49.5. And it's as if we have a randomized controlled experiment right around the cutoff. And so we're going to compare outcomes of those just above to outcomes of those just below the cutoff. Indeed, if we look post-intervention, what we would expect to see at the discontinuity is a difference. And that difference right at the discontinuity is the impact. And so to estimate this, what we would do is we would run a regression where the dependent variable is a function of whether or not you're eligible and ineligible, and the running variable. By putting the running variable in continuously above the cutoff and continuously below the cutoff, we control for differences in the outcome as you move away from the cutoff. And then the cutoff estimates the local difference between the treatment and control group at the discontinuity, and hence it becomes a regression discontinuity. In order to conduct a regression discontinuity design, we need to have a continuous eligibility index with a defined cutoff point. The intuition behind this is units around the cutoff point are similar. The non-eligible group just above or just below the cutoff makes a good counterfactual. The estimated impact is valid around the vicinity of the cutoff point. To use a regression discontinuity design, you need a conditional eligibility index and a defined cutoff point. Remember, in order to do a regression discontinuity design, We require a continuous eligibility index with a defined cutoff point. Observations just on either side of the eligibility cutoff point are good control variables. It's not necessary to exclude a group of the eligible units from the program. Often one can apply this in retrospective evaluations that meet the necessary conditions. Finally, remember that regression discontinuity design produces a local estimate of the impact at the cutoff point. However, this estimate is not necessarily valid or generalizable for other populations. Power may also be an issue, as we need to have many observations around the cutoff point.